Hey, Mr. Sams.
Yes, sir.
Why are you standing in front of the periodic table with like a...
I'm going to be the amazing element pointer adder.
Whoa! Well, let's see how that works.
Do you know the element song?
Do I know the element song? I actually do know the element song.
All right, we're going to do the element song. I'm going to see if I can...
How fast are you?
I don't know. I've never done this. We'll see.
Okay, okay.
Here we go.
There's antimony, arsenic, aluminum, selenium, hydrogen, and oxygen, and nitrogen, and rhenium, and nickel,
Crap, that's too fast.
and iron, americium, ruthenium,
Uranium.
europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and acetylene,
Uranium.
and gold, protactinium, and indium, and
Yeah,
gallium,
that's right here. I got that one.
and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, and actinium, and rubidium, and boron, gadolinium, niobium, and iridium, and strontium, and silicon, and silver, and samarium, and bismuth,
You're really good at this, Mr. Sams.
Barium.
Barium!
Right there.
You're good right now.
There's holmium, and helium, and hafnium, and erbium, and
Holmium? What the heck is holmium?
Where's holmium? I know. Lead. Platinum. Polonium. Titanium.
I got that one. That's holmium.
Cadmium, calcium, and chromium, and curium.
Barium, that's...
There's sulfur, californium, and chromium, and cyan.
Oh, no! What happened to our music? All right, I give up.
Okay, so you're not very good at that, Mr.
I'm
Sams.
not.
Oh!
Oh, it's back! No, it's not. It's gone.
Oh, well.
All right, so I'm really bad at that. I'll sing it for you in class. How's that?
Okay,
I'm better
sounds
at
like
that.
it. He's very good at it, actually.
Okay.
Okay, all right.
Yeah, bye, guys.
Mr. Sams.
Yeah,
You are not very good at that.
I know. It's so fast.
Well, yeah. But how can you do it in class?
I don't know. I could sing it better than I could point to them. I just
Yeah.
have never tried that before, so I'm like, oh yeah, that one's over here. No,
It's kind of like an aerobic activity.
something
You're
like
not
that.
very good at aerobics.
No, I don't do a lot of that. I don't do a lot of that. You
well,
do.
yeah. Maybe I should have been the jump around guy.
Maybe.
So
Oh, well.
we're studying periodic table.
Yeah.
Yeah. So on the periodic table, it's called a periodic table.
Right, because things occur
Oops.
periodically.
Well, yeah. Why is it called? What do you mean by periodically?
There's like recurring properties that show up.
Yes, recurring. So everybody, what you should do is write down that there are recurring properties. You got recurring properties.
Yeah.
I can't spell. Okay.
Who's that
so,
old guy on the next slide?
Who's the old guy? Yeah. Well, there's this old guy. You know, in 18 and something.
Something.
I think 1860,
I don't remember.
Yeah, I don't either. This guy named Dmitry Mendeleev. Hey, I could talk like him.
You can try. You
yes.
still have a mystery accent.
I don't know. So my name is Dmitry Mendeleev. What did I do?
Well, you came up with the idea of the periodic table.
Yes, you see what I did, and I was periodic table man, is I said, you know, there was lithium, and there is sodium, and there is potassium, these elements, and I've discovered that they have similar properties.
Yeah, I think you've slipped into not Russian accent anymore.
Have I messed up?
I don't know.
Okay, I go talk in Russian. Is that better?
I don't know if better is the word I'd use, but
Okay, so they
it's
have
there.
similar properties.
Oh, yes.
And you see, if you put lithium in water, it blows up. Did you know that?
I did.
I bet you did, actually. And then the sodium, you put it in water, and it
Blows
up. You put potassium in water, it blows up. Actually bigger.
Yeah.
I once put potassium on other science teacher. Not a good thing to put potassium. He screamed. Not good. Okay, that's a story I tell class sometime. But what Mr. Mendeleev did is he discovered that they have similar chemical and physical properties. So he put these elements in the same family, and that's why it's called a periodic table.
Right, and he started to organize them based on their similar properties, and he came up with...
So here is my periodic table as a Dmitry man. And it's not as clear as you probably could see, but basically he has put same elements in families because they have similar properties.
Cool.
See? Okay. All right. Okay. Resume. So, why did I put them in similar families?
Because they have similar properties.
Similar, I can't write. Properties. Okay. What do you mean by properties?
Just the way they behave.
So the way they behave. Also things like they would have similar densities.
Not necessarily color, but
Sometimes color. Yeah.
Charge.
Charge.
Yeah,
Conductivity.
yeah, things like that. So we'll talk more and more about how those families go together and what similar properties we're referring to here in a little bit.
Okay. So let's kind of talk about the different categories. If we look at the periodic table, it's kind of like a map.
Yep.
And so the first part of this is that we can talk about is that there's divided into metals
Yeah.
and non-metals.
Right. Now the key here you want to look for is the staircase.
So the staircase
Show 'em the
is right here.
staircase, yeah.
Now, if on your periodic table, everybody, if you don't have it out, would you pause the video, and I want you to get out your periodic table, and I want you to copy the same stair step that I have kind of highlighted
If it's
here.
not there already.
If it's not there already.
Yeah.
Now, if you're watching this on internet land, you need to still do this. And the metals are the substances on the left side of the periodic table, and then the non-metals are the right. Now, there's one that's kind of weird.
Yeah, the metalloids or the semi-metals they're sometimes called. Those are the ones that sit on the staircase there.
And there's one more, though, I was thinking about, actually, Mr.
Oh,
Sams.
sorry.
And that would, of course, be...
Oh, hydrogen.
Yeah, hydrogen is actually
weird.
a non-metal. He's kind of like the orphan child of the
Yeah.
periodic table. He's over on the left, but he kind of belongs on the right, but he
Yeah.
still belongs on the left. So let's kind of talk about the differences between, and actually, so metals versus non-metals. And the non-metals, of course, you should write down are these. So let's do a short little video to kind of show the difference.
Okay.
Okay. So here I am. I've got the periodic table here. Here you can see the stair step right here. Stair step. Non-metals are up here. Metals are here. Okay, and the semi-metals are on the side. Now I have some metals. Now take a look at the metals I've got here. This is a piece of copper. Okay. This is another piece of copper. And then I have a piece of lead, and this is aluminum. Now, one thing I want you to notice about metals is that they're all shiny. That's called, what is it called, Ms. Sims?
Luster.
They're called luster. So they are shiny and they have luster. Now, also one thing to note is that all metals have a similar color. They're sort of a silver-colored metal.
You got
Right.
other colored.
With the
one.
exception
Oh,
of two.
exceptions. There's always
There are
exceptions.
two exceptions are copper and actually right here. What would that be on my finger?
Gold.
Gold. So the two exceptions are copper and gold, but all other metals. Now, if we look back at the periodic table, most metals, there are, 80 metals or so. The 80 metals are all silver colored, with the exception, of course, of copper and gold. All right?
Okay.
Now, let's talk about non-metals. Non-metals are not shiny. They are dull. Okay, so here is a piece of carbon. It's graphite. And so this is a piece of graphite. Notice it's dull. It's kind of not so shiny. And it's kind of boring. Okay?
Yep.
Another example would be sulfur right here. And if you look at the sulfur, it's kind of a yellow powder. Okay. One thing also true about nonmetals, they don't conduct electricity, where the metals right here, they do conduct electricity. And then lastly, the things that are kind of in between on that stair step, they're called metalloids. And this is a wafer of silicon. Okay? And it looks kind of shiny and kind of not shiny because it's kind of in between. And actually from a conductivity, metals conduct, non-metals don't conduct. Semi-metals or
Semiconductors?
are called semiconductors. That means they kind of conduct.
Cool. Now, I notice you have a sheet of copper right there.
Yes.
Is that another property of metals?
Yes, well they are malleable. You can bend them. See, I can bend this. It's malleable. I can take like an aluminum can is also malleable. We probably know that. So this
You can bang it out into a sheet, and you can also pull it into a wire.
yeah, that's called its
Ductility.
ductile, is that you can make it into a wire. Okay?
Cool.
So metals, non-metals, and semi-metals. Well, Mr. Sams, we don't only just talk about metals versus non-metals,
No.
but each family kind of gets its own
Yeah.
deal.
Now, by family, you mean a column, right?
Yes, a column. Now, on the periodic table, the alkali metals is the first column of the periodic table. Now, you might notice...
Not hydrogen?
It doesn't include hydrogen. So
It's
what I want
hydrogen.
everybody to do is to label this, and at the top of this, write, well, there it is, alkali metals, okay?
Okay.
Now, alkali metals are kind of cool, so let's play around a little bit with an alkali metal.
Let's do it. Okay. Now, Mr. Bergman, I got some sodium here, and sodium's an alkali metal.
Oh, yeah.
Yeah. Now, this says do not open or tip. Any idea why that might say that?
Because it's very dangerous.
Yeah, it is very dangerous.
Oh, and that's a huge piece of
This
sodium.
is
Oh, my
huge.
gosh.
I didn't realize we had this much stuff, and we really need to repack this.
Yeah, I think we need to add some more oil to that.
Hang on, kill that. This is a piece of sodium here, and you can see I can squish it. It's malleable.
And
Okay.
it doesn't look very silvery, Mr. Sam.
No, that's because it's got a little coating of probably sodium oxide on the outside, or some sort of oxidized. It's reacted a little bit on the outside. If I cut into this,
Why don't you cut into that with our cool tweezer thing?
yeah, it's shiny on the inside.
Yeah, I can see that. Yeah.
So you can see how it's shiny? Yeah, so if I cut into it, it's nice and shiny. And so it's got the properties of metals. Now, you don't often think of sodium as a metal. You think of sodium as like, something in salt. And it's the same metal, it's just in a little bit different form. And we'll talk about how those get formed a little bit later. But there it is. That's an alkali metal. Now, if I threw this in water, it would blow up. And we'll do a little bit of that in class. And we got a really cool video. We'll show you about that in class, too. So have fun.
Okay. And so the next type of element is the second column on the periodic table, and these are the alkaline earth metals.
No, you know, one thing we didn't say about the last slide is those alkali metals, when they form charges, they form +1.
Yeah, actually, that's a good point. So
charges.
put +1 up top here, and then you want to put +2 here.
Yeah, these alkali earth metals, they form +2 charges.
+2, right, everybody?
Yes,
+2.
And we'll talk more about what that means later, but you just need to know that right now.
Now let's do a little quick video clip about alkaline earth metals.
All right.
Okay. And now, of course, we're talking about alkaline earth metals. These are alkaline earth metals. This happens to be little slivers of magnesium. This is magnesium, okay? So magnesium, magnesium turnings, and this is a magnesium ribbon. And so you guys will be doing quite a few experiments, particularly with the magnesium ribbon right here. Notice that it's just malleable. I can bend this, you know, and drop it on the table and all kinds of things. Okay? So that's an alkaline earth metal. Well, the next family, Mr. Sams, is noble gases. Noble gases is the last column on the periodic table, and they have no charge. So put a charge of 0 at the top there. So that's the noble gases.
Why don't they have a charge?
Well, because they're
noble?
They're noble. All atoms want to have the same number of electrons as a noble gas, and
so they don't,
noble gases are the ones that are sort of happy guys.
And then they just don't react.
And they don't react.
Usually.
Yeah, okay. They're boring. They're all, by the way, gases, hence the name noble gases.
Yes, amazing.
Yeah. Well, what about halogens? Halogens is the second to the last column, and so we want to write halogens. There's the name, halogens. You get halogen lights. You've heard of those probably, light bulbs, and their charge is -1. And so you want to go ahead and write that up there. Okay?
Now, when we say charges, we should also point out that as pure elements, they don't have a charge, but when they form things with charges called ions, that's when they get those particular
And we'll
charges.
talk about that in a subsequent podcast.
Yep.
Okay, so but if you are, make sure you're pausing the video, everybody, to write these things down.
Right. Label your periodic table.
Yeah.
Label the table.
And now I want to talk about halogens. Halogens are the second to last column on the periodic table. And note, first of all, that we have bromine. And I got some bromine in this tube. It's kind of a brown gas, kind of liquid. It's blue on the periodic table, at least on this periodic table, representing that it's a liquid at room temperature. This one's a gas because it's been warmed up. Okay? And then I have iodine gas. It's actually a solid, but as you evaporate it, it kind of forms the coat. This is kind of, you can't really see it, but it's really a brown substance. So these are the halogens.
Yeah, and the crystals are purple for iodine. That's kind of pretty. As a side note, what do you do if you see a colored gas?
Run.
Why did you have to run?
Because all colored gases are poisonous.
Oh, so the ones that you're holding in your hand, if those opened up, we'd need to evacuate the room?
That would be a...
Okay,
yes.
just checking.
Good FYI. Okay, thanks. Transition metals, there's no set charge here. The transition metals are essentially the metals in the middle of the periodic table. These are the transition metals, the metals in the middle. So these are your transition metals. So label those. You can't put charges at the top.
Yeah, because they have all sorts of different charges. Some of the elements even have multiple charges, like iron can have +2 or +3 charge.
No, I actually call them the schizophrenic metals.
Yeah, not sure where they are.
They don't know which way to go. Yeah, so they got multiple personalities like that. Rare earth metals are the ones in the bottom. They are called the rare earth metals because they are found rarely in the earth. They're sometimes called
inner transition
metals. So, but let's just call them rare earth metals for the sake of argument. And then metals and semi-metals, that's the ones that are along the stair step. And the most classic one everybody knows is silicon. Mr. Sams, I think that kind of cleans it up. We're about done here.
Antimony, arsenic, aluminum, selenium, and hydrogen and nitrogen and oxygen,
barium,
uranium, and nickel, neodymium, neptunium, germanium,
lead,
and iron, americium, ruthenium.
You're pretty good at that.
Uranium, europium, zirconium, something. I don't remember it.
Okay, all right. Mr. Sams and his musical interlude. Woo! Next day. Bye-bye.